In this video, we're going to talk about the time value of money. And the formulas for this particular video can be seen here in the right-hand side. Now, some of the formulas are a little bit more complicated than others, and when we go to solve those problems, I'll show you what those formulas are. But they are pretty complicated formulas. But let's just talk briefly about future value. We want to make an investment today, and the question is, what value will that grow to if it earns a certain percent of return on average per year? So let's assume we want to invest $1,000. If we assume that the interest rate we can earn is 10%, and we invest for 1 year, the only other variable that we need now is compounding frequency. Now, before we talk too much about solutions, let's talk about the variables. The time value of money essentially is just a big algebra question. The future value is, again, it's pretty obvious maybe. It's the value that you expect to have in the future. The present value is the value that you're going to invest today, or what an asset is worth. This is interest rate per year and time per year, or time in years. In the financial world, we can actually calculate interest at different frequencies. The most popular is monthly, but dividends are paid quarterly. Bonds pay interest semi-annually. And just to make life simple in the beginning, we're just going to assume that the compounding frequency equals 1. In addition to that, when we get to some other types of payments or other types of problems that require payment discussion or annuity discussions, we'll talk about these variables below. But one of the things we always have to remember is that the computer or any financial calculator will calculate the values with the expectation that the cash flows occur at the end of the period. So in this case, we're always going to assume that what we refer to is as an ordinary annuity, or is that the cash flow occurs at the beginning of the time frame. The alternative is it would happen at the end of the time frame. And if you see the formula over here, you can see that this very last variable, D15, is this variable. So we're telling it that we want it to calculate this value as of the end of the year. So in this case, if you invested $1,000 at 10% for 1 year, that value will be worth $1,100 1 year from today. And of course, 10% of $1,000 is 100, so you would end up with $1,100. Now, there are some other questions that we can answer, and we'll talk about them specifically in other videos, but let's just briefly describe some of the issues that come up with calculating the time value of money. The first issue that we can talk about is compounding frequency. As we mentioned, the most popular is 12 times per year, but it could be once a year, twice a year, 4 times a year, 12 times a year, or it could be daily, and that could be 365. So what we can do is we can change this frequency. Now, 2 things will happen when we change this frequency. Number 1 is we should see a change in the solution number, but also the other thing that we're going to be looking at is this concept down below here called the effective interest rate. The annual interest rate is sometimes referred to the stated rate. That's the nominal rate. And the effective interest rate is the actual interest rate that you earn. So in this case, let's change compounding frequency from 1 to 12. If you notice the solution, the future value is $1,100. If I change this to 12, we see now I have $1,104. So I invested the same amount of money, same rate of return, same time frame, but now I have more money. Since I have more money, that must mean the interest rate changed. So in this case, the effective interest rate was 10.47. I actually earned more than the annual rate of 10%. Other questions we can answer are, I think, a little intuitive, right? What happens if we invest for a longer period of time? What if we invest for 2 years instead of 1 year? If you increase the time, you increase the value. But in this case, let's think about it. $1,000, 10% of 1,000 is 100. For 2 years is 200. But we have an extra 10% or extra $10. That is 10% of the $1,000 that we earned at the end of the first year. What happens if we change the interest rate? Of course, if we change the interest rate, we change the solved value. So in this case, 5%, we would only have $1,050. Now there is another line item here called the future value with continuous compounding. This essentially, I like to refer to it as being kind of a theoretical value. If interest could compound instantly, what would this be? And the answer is, it's $1,051.27. So occasionally you may be asked about continuous compounding. Again, it is something that I like to think is a little bit more theoretical than practical. But we can also ask other questions, right? So let's say this $1,000 grows to $2,000, and we would like to know if that happens in 1 year, what is the interest rate? So we need to delete interest from the cell. And what you'll find is, if it grows from negative 1,000 to 2,000, then the actual interest rate would be 100%. Now, one thing I neglected to say, and I should have said earlier, the present value cell, 99.99% of the time, will always be a negative number. So you'll always input it as a negative number with, again, rare exceptions. Another question might be, well, how long does it take for my money to double? So let's say we could earn 8% on our money, and we want to ask how many years that will take. If we, again, delete the time in years, and again, as you notice, this is really just an algebra question. There are really 4 primary variables for time value of money for a lump sum, and we are just solving for one of the missing variables. In this case, the missing variable is time. And again, you see down below here, the effective interest rate is roughly 8%. Oops, I'm sorry, wrong number. The time is 9.01%. And this is actually relates to there is a estimate, if you will. It's called the rule of 72. And if you divide the interest rate into the number 72, it tells you how long your money takes to double. So that's the basics of time value of money.